Right, so in question 5 here, sorry, in question C, 2C from our workbook. So we know we've got 2 parallel lines, which may help us. It may not be useful, but keep that in mind. We have an angle at the center, which is 110. And we have 2 angles at circumferences that we need to find. So what we'll do here, we notice that DOC is 110 degrees. So this is angle at the center. And we have 2 angles, A and B, which are at the circumference. So angle A and angle B are at the circumference. So what we know is that the angle at the center is 2 times angle at circumference. So the angle at the center is given, which is 110. 2 times angle at the circumference. We have A and B. So let's just do A first. So then we can divide both sides by 2. We'll get A is 55 degrees. And then we can also do the same for B, because remember A and B are the same angle. So we'll have 110 is 2B, and then divide both sides by 2. Cancel out. We'll get B is also 55 degrees. So that's showing the full working to get A and B. So that's done. Now we want to find angle C, which is this angle down here between OC and CD. And we should recognize that we have 2 equal lengths here, which is the radius on both sides. We don't know the radius, but we know that they're equal. So that means that this angle here is also C, isn't it? Because base angles of an isosceles triangle will have the same angle. So we can call that angle C as well. So for that part, to find C, we can make an equation. So we'd have C plus 110 equals 180. So 2C would equal 180 minus 110. 2C would be 70. Divide both sides by 2. You'll get C is 35 degrees. So this angle here, 35. And also that side is also 35. And when you add the 3 angles, you should get 180. So in question 2A here, we've got angle X that we need to find, angle Y and angle Z. These are the 3 angles that are unknown. We need to find them. Now, the first thing you should recognize for angle X, look at this rule here. So we're using the angles in the same segment rule to find X here. So do you see the shape which resembles a butterfly? So X go up to 40. So that means that X is 40 degrees. We know that straight away. And we can say angles in the same segment. So get used to writing the rule too, like that. So X is 40, so we can write 40 here. And then what you see is that now we have a triangle, an isosceles triangle here. Okay, so now we have angle 40 up here, and with an isosceles triangle, the base angles will be equal. So that can be written as Y as well. So now we can form an equation to find Y using this triangle. So we would have Y plus 40 equals 180. So this is angles in an isosceles triangle. So we'd have 2Y equals 140. So divide both sides by 2. You get Y equals 70 degrees for Y. So we'll add that in. down here. So this is 70 now, and this angle is 70 here. So it should be pretty easy to get Z because we know the sum of these angles, which we call supplementary angles, these will add up to 180. So to find Z, Z plus 70 will be equal to 180. So this is angles on a straight line or supplementary angles. So Z then would be 180 minus 70, and you'll get 110 degrees for Z. So Z is 110. So to recap, X will be 40 degrees, that's here. Y is 70, the base angles of this triangle. And then we use that 70 to find Z, which is here. So we could write that in as 110 degrees. So in this question here, question B, we need to find X and Y. These are our two values we need to find. Now, when I look at this picture, I can see my shape here. See how we have our butterfly shape? Like that. Kind of a weird looking butterfly. They're the wings. But we know that the tips of the wings, if we think about them like that, this angle is X, isn't it? So you could write X there if you want. We may not need to know that. But also, importantly, this is 73. So that means that this angle down here is also 73. 73 there. Okay, so we've got 73 down there. And what else can we find? Let's just clear the yellow out. Okay, so we've got 73 down here. Let's put it in. So we could say angle LON, so LKO equals angle MNO. And that equals 73. So this is angles in the same segment. So this is 73 down here. Doesn't look like it helps yet, does it? But what we know now is that this angle here can be calculated, can't it? So this angle here, JKO, is going to be 180 minus 73. So that's angle on a straight line. So there, you're going to get 107. So this angle here is 107 degrees. And we note now that that is also going to be the same, 107 degrees, because you also have 73 degrees here, right? So JNO is also 107. I won't bother writing that here, but we can see from the diagram. So now we need to get Y. And we note that the four angles in a quadrilateral will add to 360. So we would have 52 plus 107 plus 107 plus Y equals 360. So if you rearrange that, you'll calculate Y to be 94 degrees. Okay, so now we have Y. I'll do it in red. So that would be 94 there. Okay, so now we can actually calculate X, because if you see this as a triangle, there's a couple of ways to do it, but I'll just use this triangle here. So we see there's a triangle here. You can also use this LKO triangle as well to do it. But we want to find X. But we already know two of the angles. We know this is 52. We know that this is 107. And this angle up here is X. So when you add 3 angles in a triangle, you'll get 180. So this is angles in a triangle. So when we calculate X, then we're going to get 21. Okay, so there are 2 answers. So this is going to be 94 for Y. That was an intermediate step there. And X is 21. So these are our 2 answers here. Okay, so for question 2 here, we want to find the value of X, Y, and Z. And in the question, it says that XV is the diameter here. So this line is going to be a diameter line, which will help us a little bit later. Oops. Clear that out. So, okay, we want to find X, Y, and Z. And when I look at this, I'm thinking about what rules can I use? Okay, so if I look at my angle in the same segment rule, I'm going to have this shape here, aren't I? You see that? So that means that by the angle in the same segment rule, that Y is going to be 53. It's going to be this angle here. Okay, so I can say that Y equals 53 degrees. So there's angles in the same segment. So this Y here is 53. So let's tidy that up. So we're going to have 53 here. And because this is through the center, now you have this triangle here. Okay, which means that this angle here is going to be a right angle. So we can say that 90 minus 53 will be Z. And so this is angles in a semicircle. So angles in a semicircle. So then Z then would be 37 degrees. So this Z is 37. There, we'll put it in there. Now you should be able to find X. So let's take the blue out there. Now look at your shape again. Now look at it in this direction. You see that? We got our butterfly shape, but going in a different direction now. And when you look at that, we could say that X and Z are going to be equal. So X equals Z. So that's angles in the same segment. Okay, so these 2 angles are equal. And so then you can say that X equals 37 here. So that would be 37 as well. So they're your 3 angles. So Z 37, Y 37, and Y is 53, and X is 37. They're your 3 angles in that question.